In today's video, we're going to be creating a mobile bookings application from scratch using Flutter and walk through how to get the most out of related developer tooling. Flutter is a great way to build cross-platform applications targeting Android, iOS, Windows, macOS, Linux, and the web, all using the same Dart codebase. And with great tooling, thanks to the resources and support of Google who are behind the project, it also has excellent documentation and frequent updates. To show the advantages of using Flutter to build your next mobile app, we're going to walk through creating a new project from scratch and end up with a working bookings management UI. To follow along, you will need the ServiceStack.NET X tool, the Flutter SDK installed along with Android Studio. The full source code to this bookings application will be up on GitHub, and I'll leave a link in the description if you want to have a look at that yourself. We also have a video building the to-do app equivalent from scratch that also might be useful. To start things off, we're going to use the ServiceStack.NET X tool and the command x new space view-mjs space bookings app. This will create a .NET solution with some example services, including a bookings management API and a Vue web interface, enabling us to focus on the mobile client development experience. Opening the solution with your favorite .NET IDE and running the application, we now have a Vue.mjs application with booking services example all running and ready to go. To create your Flutter application, we can also use the ServiceStack.NET X tool using the command xmixflutter in the root folder of your project. This will come already integrated with your application's Hello service, and opening the new Flutter application with Android Studio, we can run our application in an emulator and see our example already calling the Hello service and displaying the response. For this booking app, we will be using the existing services in our .NET application. These are auto query services where we only have our database model booking declared along with each CRUD operation of query, create, update, and delete booking as the request DTOs. To have typed end-to-end services, we're going to need representations of these classes on our client as well. So, just like working with ServiceStack services from most other major languages and development environments, we have server-generated request and response data transfer objects that are used to call our own API. For this Flutter example, these classes are in the Flutter project's lib folder under the DTOs.dart file. Currently, we only have the Hello service related to the request and response DTOs that came with the Flutter Mix template. But with our server running, we can rapidly update this file either with the integrated IDE tooling from ServiceStack or by running the ServiceStack.NET X tool with the command xdart from the root project directory. This means as you change your services during development, you can quickly run the xdart command or use your IDE to update your client projects quickly. This will get all the updated request and response DTOs from your server to give you typed end-to-end web APIs. Here we can see our DTOs.dart file now contains our bookings related requests and response objects, and we can move on with developing our bookings application. To kick things off, let's create a new stateful widget to view our bookings to replace the default Hello page in our example. This will take a title to display on our app bar, and will also need access to the same iService client in our main.dart file to make our requests to our server API. Now that our widget has access to a service client, we can create a query and refresh function to fetch our bookings data. Our iService client uses the query bookings request DTO to get a typed response back of query response booking, where booking is the type of our model. The refresh bookings method then uses the query bookings function to fire and forget an update request of our bookings data that we're going to display. To load our bookings initially, we will need to hook into the add post frame callback method of the widget's binding singleton, so we have data populated to render our bookings as soon as this widget is used. Now that we have some data, we're going to create some methods to create individual table cells, headings, and rows to construct the bookings table itself. This will allow us to format as we need each column of data, as well as consider screen size by skipping less important columns for smaller screens. This is where the typed response DTOs really start to help us, since we are passing around an array of the booking type, which is a local Dart representation of the booking model on our server. This helps us avoid simple typos, enhances error messages in our IDE, as well as giving us better syntax highlighting and autocomplete. With our create table methods completed, we can utilize the Flutter hot reload function to iterate quickly and test our changes. So now that we've listed our bookings on the screen, let's add some interactivity to our application. First, we will add the ability to delete bookings with a bin icon on the right-hand side of our table. For this, just like the query, we will create a delete bookings method that uses our client taking the selected booking. We can then add a column for this icon and bind it to an onPressed event that calls our new delete booking method. When the delete call is finished, we refresh our data showing our updated list of bookings. Our delete booking request isn't actually deleting any bookings on the server yet because it requires an authenticated user, updating our iService client in the main.dart file to be initialized as authenticated, and now our request is being processed. Now that we can query and delete bookings, we can move on to the create and update functionality. To trigger a create event, we'll bind to the floating action button, which is a part of material design. To reuse our form control, we will create a separate booking form.dart file. Our new booking form stateful widget will take an optional booking to support updating, and it will also use the iService client to call the backend API. Next, we're going to add a new dependency to help us create this form, specifically the reactive forms library. This will greatly cut down the code we need to write for our forms, and it will also let us to define client-side validation if we need. First, we will define our form group and relate the form controls and types to each of our bookings properties, common to the create and the update bookings request DTOs. In the body of our widget, we will use the reactive form builder to construct the UI for our form. Form control names are populated with matching keys associated with the form group, which takes care of the binding of our forms for us. We will then use a reactive form consumer to bind an event to submit the form itself. The builder passes an instance of our form where we can access the data of each field. Next, we will create a method to handle both the create and update requests to the API, but let's just implement the create for now. We pass each control value to the create booking request DTO and use the iService client to post the details to our API. Our UI updates after the creation of our booking by using the navigator.pop method to go back to our bookings table, which then invokes our data to refresh. To add the update functionality, we can use a lot of what we already have by passing an instance of our booking model to our booking form. We can then override our init state method of our booking form and populate the values of our form controls if the booking instance isn't null. This means our form will now display with all the data from the booking instance. We can then modify the create or update method to support the update request DTO, and now we have the ability to edit a booking from this form. This whole time we've had both our front-end Flutter client running alongside our ServiceStack server, making iterations fast with hot reload. And iterating on both client and server at the same time can also be quick even while maintaining type safety between your client and server. To show this, let's add support for sorting our bookings by column. First, we will add the order by desk property to the query bookings request DTO on our server in C#. Since we are using .NET Watch, we can add the property to the query bookings C# object while the server is running. If we look at the ServiceStack UI which comes built in, it shows the generated Dart code for our application, specifically for the query bookings API. We only have the int ID in this request DTO before the change, but now adding the new property and saving, the UI Dart code generation is updated and shows the new order by desk string property. We can now jump back to our Android Studio Flutter application, use the IDE integration to sync our request and response DTOs, and our IDE gives us all the type information associated with our server change. This level of integration gives confidence that your client-server communications are going to work the first time. You don't need to guess the name or casing of the properties or classes of the request and response DTOs, or even remember what route path to use to request a specific API. As your API grows in complexity, these type-safe integrations become more and more important as your mental map of your API becomes harder to hold in your mind all at once. ServiceStack's message-based approach and end-to-end type safety for clients relieves that cognitive load, enabling you to better focus on the changes you need to make and improving your ability to deliver solutions faster. Well, that's it for this video. If you have any suggestions or feedback about our templates or videos, let us know in the comments. If you want to know more, check out our other videos and join us in the ServiceStack community through our Discord and GitHub discussions. ServiceStack is free for individuals and open source projects, so anyone is welcome. And as always, thanks for watching.